Hello everyone, today we are going to discuss some objective type questions of mechanical properties of solids. Your first question is, the change in the shape of a regular body is due to shearing strain, bulk strain, mental strain or longitudinal strain. The change in the shape of a regular body. When a body is under the effect of deforming force, there is a change in the shape of the body without changing in its volume. So the strain produced is called your shearing strain. Okay. Next, the Young's modulus of a perfectly rigid body is unity, zero, infinity or non-zero constant. Your Young's modulus of elasticity. Young's modulus Y is equal to how much? That is your normal stress by longitudinal strain. Yes, and for a perfectly rigid body, your strain is zero. What is strain? Strain is change in configuration to the original configuration. It may be length or volume or whatever. For a perfectly rigid body, perfectly rigid body, strain is equal to 0. That means strain is 0. That implies your Y is how much? Is denominator is 0. So Y is infinity. So your option C. The Young's modulus of a perfectly rigid body is infinity. Next, Young's modulus for a perfectly plastic body. For a perfectly plastic body, Y is equal to stress upon strain. For a perfectly plastic body, your stress is 0. Yes, as there is no restoring force in a perfectly plastic body. So stress is how much? Stress is equal to restoring force per area. If there is no restoring force, then stress is 0. That means Y is equal to 0. Next, the reciprocal of bulk modulus of a substance is called its compressibility, rigidity, viscosity or modulus of elasticity. It is called your compressibility. Yes, compressibility is equal to your reciprocal of bulk modulus of elasticity. The relation between Young's modulus Y, bulk modulus K and modulus of rigidity eta is, we know that this relation is 9 by Y is equal to 1 upon K plus 3 upon eta, but this is not given. It is 3 by Y, 3 by Y or 1 upon Y, 1 upon eta. So divide this equation, divided by 3. So it is 3 upon Y is equal to 1 upon 3K plus 1 upon eta. It is given 3 upon Y, yes, plus 1 upon 3 by Y is equal to 1 upon eta plus 1 by 3K. Yes, that is option B is correct. The property of metals which allows them to be drawn readily into thin wires beyond their elastic limit without rupture is known as malleability, ductility, hardness or elasticity. It is called your ductility. And option B. And the metals which ruptures just beyond elastic limit are called your brittle. Yes. Next. With rise in temperature, the Young's modulus of elasticity decreases, increases, changes irregularly or remains unchanged. Young's modulus of elasticity, always Y is equal to stress upon strain. As temperature increases or with rise in temperature, strain increases. Strain increases. That implies your Y decreases. As denominator increases, that means Y decreases. So option A. Energy per unit volume of a stretched wire is half of stress into strain, load into strain, half of load into strain. Yes, it is energy per unit volume is equal to half into stress into strain. Yes, so option A. When a wire undergoes a linear tensile strain, it experiences a lateral contraction also. The ratio of lateral contraction to longitudinal strain is known as, here, that is, what is the ratio? That is lateral contraction or lateral strain upon longitudinal strain. This quantity is called here, this is called here Poisson's ratio, which is unitless and dimensionless. Yes. When an elastic material with Young's modulus Y is subjected to stretching stress S, the elastic energy stored per unit volume of the material is, what is given? Young's modulus is given Y and stress is given S. Then it is asked the relation or expression for elastic energy stored for unit volume. We know the energy stored for unit volume is how much? Is equal to half into stress into strain. But this option is not given. Yes. So again we know Y is equal to how much? Stress into strain. From this we can write strain is how much? We can write this, yes, strain is equal to stress upon Y. Yes or no? Yes. Now substitute this in energy stored for unit volume in this expression. That is E is equal to how much? Half into stress. In place of strain, we can write stress upon Y. Yes, that is equal to half into stress is denoted as S. This is S and Y. This is equal to half of A square upon Y. It is given? Yes, option C. Okay, next. The potential energy of a stretched spring is proportional to the square of the force constant, the square of amount of stress, the square of the original length, or none of these. Yes. The potential energy of stretched spring, here how much? Potential energy is equal to half of K x square, where K is here spring constant. Yes, K is here spring constant and X is the amount of stress of the wire. Yes, so your option B, it is proportional to X square, that is potential energy is proportional to X square. So option B, the square of amount of stress. Okay. Thank you. Have a nice day.